Okay, let's talk about all the different angles that can be formed inside of a circle. And we actually have 4 different scenarios here that we're going to talk about. And we have a different formula for each one, but they're really easy to remember. The first one being anytime that your vertex, and this is the location of the vertices here, anytime your vertex is the center of the circle, let's start there. If the vertex is the center of the circle, this is called a central angle. And anytime the vertex is the actual center, we simply say that the angle is equal to the arc. So if this vertex here is at the center, so therefore if the arc is 80, then the angle is 80. Now, a lot of times I'll reference to this as the arc that's in its mouth. This angle looks like a mouth, kind of like a Pac-Man here. So this arc right here is the one that's inside of its mouth. So whatever the measure of that arc is, that's also going to be the measure of the angle. The second scenario that we have is what if the vertex is actually on the circle. Now we call this first type, this is going to be what's called an inscribed angle. Let me draw it real quick. So anytime the vertex is actually on the circle, we simply look at the arc that's in the circle's mouth, or in the angle's mouth, and the measure of that angle is going to be half the measure of that arc. So therefore, since the arc is 80, the angle will be 40. And let's draw one more of these just to show you something. That if I were to take and draw this, notice the exact same arc is inside of that angle's mouth, so therefore it would also be a 40-degree angle. Now, another scenario that you have here, let me erase these. Another scenario you have here is what if you have an actual semicircle inside of its mouth? Let me draw this line and this line. And notice inside of that angle's mouth is this whole side of the circle. You could actually draw a line right here and divide the circle into half. So anytime an angle is eating a semicircle, that angle would have to be a 90-degree angle because it'd have to be half of 180. Now, the third type scenario is we're talking about what if the angles are inside of the circle, but it's not the center. So let's draw 2 what we call chords here. A chord is a line segment whose endpoints are actually on the circle. So therefore, anytime we have a set of chords that cross inside, then we're going to do half the sum. So inside of this angle's mouth is this 80-degree arc. Inside of this angle's mouth is this 40-degree arc. And again, we know that these 2 angles here are vertical angles, so they're going to be the same size. So it really doesn't matter which one we're talking about. So we simply find half the sum, which means we're going to add these 2 arcs. We get 120 degrees. We're going to take half of that dividing by 2. So you have 2 60-degree angles. And then the last scenario is what if the angles are, the vertex of the angle is actually outside the circle. Now we're going to half the difference. And I've drawn me some lines here so that I can keep it a little bit straighter. Let me pull these lines down. And these 2 lines are called what we call secant lines. They form chords on the inside, but 2 lines are a line that crosses at 2 different points. It intersects 2 different points on that circle we call secant lines. So in order to find the angle formed by 2 secant lines, again, we're simply going to do half the difference. So we're going to take the 2 arcs that's in its mouth, which is the 80 and the 40. We're going to do the difference, which is subtraction. We're going to subtract the 2. We get 40, and we're going to take a half of that. And that tells us that this is a 20-degree angle. Now let's look at one more scenario. What if, let me go ahead and erase this one. And what if I were to draw a tangent line with that secant line? Now, a tangent line skims, let's see if I can draw this. A tangent line skims a circle at a single point. So that would be a tangent line if it were to continue on forever. And if we were looking for this angle right here, again, the rule is anytime the angle's vertex is outside of the circle, we're going to do half the difference. So therefore, we got to be careful about what arc is in, what 2 arcs is in the mouth here. So the first one's going to be this 40-degree arc, and the second one inside this large mouth here, this large angle, is going to be this. We'd have to add the 2 together, and 80 and 40 gives you 220. Again, the first angle is 40, the second angle is 220. So therefore, again, we're going to do half the difference. So we're going to do the 220, the larger arc, subtract the 40 from it, we get 180 degrees, and we find out that this would actually be a 90-degree angle.